Hey everybody, Garrett from AppMap here with another runtime analysis rule video. If you missed our first one, which has to deal with updates and GET requests and making sure that we have safe practices in our web APIs, you can find links to that in the description down below, or in the upper right hand corner, I'll leave a card for you. If you don't know what runtime analysis is, I have a video describing how AppMap actually applies runtime analysis and how to set it up in AppMap and how it can help you in your daily development environment. Links to that in the description down below and in the upper right corner as well. But let's go ahead and get started. The rule that we're going to be playing with today is our very first security rule, and it's called authorization before authentication. These are two things and two terms that often get confused or mixed up. So let's break it down pretty simply into two different pieces. The first one being authorization. Authorization is the process by which we identify which users have access to what resources, whether that be endpoints, locations in our application, data, doesn't matter. The process of knowing who has what access, right? The second half of that is the authentication piece. Authentication is the process by which we identify a user and provide them an identity in our system to let us know who they are. So it stands to reason that we should probably know who somebody is before we give them access to whatever it is that we're trying to restrict. So let's look at a real world scenario. A lot of the times this happens in development environments. For whatever the case is, whether we're doing it for ease of use, whether we're doing it for testing, we often blanket authenticate our dev environments and authorize things that you shouldn't have access to. So if we come here, we're going to just take a real quick example. We're going to take a look at our awesome AppMap e-commerce store. Just for reference and just so everybody knows, unfortunately, none of these awesome t-shirts, hoodies, or bottles are actually available for purchase on this website. But if you would like some swag, go ahead and join our community Slack channel. A link to that is down in the description below. We do swag giveaways all the time, or you can just hit me up and I'll see what I can do. So moving on, we've got this awesome e-commerce store, right? We have all this stuff. And if you've ever been on an e-commerce store before, you know probably one of the easiest ways to determine if you authenticate is to click right there on the cart. If you're on Amazon and have anything inside of your cart, yes, it shows our cart is empty right now. But if you're on Amazon or any other e-commerce site and you have things in your cart, oftentimes when you click the cart, it will pull up some form of authentication, some form of sign-in form or whatever the case may be. And you'll notice that didn't happen here, right? So we can come back here to the merch store. It doesn't matter. Every time I click on this, it's not going to pull up the authentication. So let's go see what's going on inside the code. If we come over here into this demo is actually a Rails demo built on Ruby on Rails, and it uses something called Spree. Spree is a open source e-commerce site or open source e-commerce platform that does all sorts of management of like product management, inventory management, checkout management, cart management. Makes it really easy. That's why we built it on that. So if we actually go take a look at AppMap, and we take a look at our overview, just like we did last time. I know I just went right over here to the side and I clicked on overview. This is our runtime analysis tool. So in generating app maps, as we went to that cart, it generated an app map for us. And we can see this pops up, authorization performed before authentication. Let's go take a look and dig. And we can see that that was found in 17 different app maps. When we look at the actual rule itself and a violation of that rule that app map finds and catches, what we actually get and we look at that finding is a brief definition of the rule. You can click here to learn more. It'll kick you over. The event summary that happened, and we can see that it's coming from CanCan controller additions. CanCan is a library that helps us do our authorization for different endpoints and for other different resources within our application. We can see a reference to its common weakness enumeration, which if we click that, it'll just jump us out to the common weakness enumeration. And we can see a stack trace of kind of where it came from. And as I'm looking at these, I can see that I actually don't have access to any of these controllers. They come from the libraries that we're actually using. So it looks like our processes of authenticating or authorizing are happening in our application from these libraries before we can get to them. Let's go double check that and make sure. So if we take a look here at the very first app map, we found it in 14 app maps. That's not good because it's a security risk, but let's go take a look and it'll open to our trace view and we can see CanCan controller authorize. Now, I like to see things most of the time inside of our sequence diagram. So if I go here to show in sequence, it'll actually show where that call happens. And I can kind of scroll over here and I can see what called it. I don't see an immediate function that called it. So I'm actually going to hop back over to our trace view. And if you look here up in the upper right, we can navigate backwards to the actual get cart event that happened that called it. So let's view that in our sequence diagram. If we view that in our sequence diagram, we see get cart processes the action. And as we scroll down here, just scanning, I can see a secure compare. I can see a user, but I see a guest token happen. That's not good. Well, you should probably authenticate a user there. Not that a guest token is bad, it's just we should probably, if a user is there, authenticate before we authorize. And as we keep scrolling down here, we can see, we're just going to keep looking. We can see our authorize function right here. That authorize that comes from CanCan, nowhere in there did we see an authentication. We saw a guest token get set, and we see an authorize. As we come back down, we can see where that authorization is being sent to. It's actually being sent to spree order, whatever that is, because we don't have access to that. But if we take a look at our get cart, let's go back to our trace view. Let's take a look at our authorization that actually happened, and we'll see that in the dependency map. We can see the CanCan controller additions goes ahead and sends to our Solidus core. And inside of our Solidus core, we can see that that controller addition got sent to spree. So, like I said before, we don't have access to spree. It's not within our application anywhere. The core of it is actually out inside of the spree documentation that we could go take a look at if we needed to, but that presents us with a problem. So, since we don't have access to it, we need to change our order. We probably need to go authenticate our user before we ever touch anything with spree, which means we need to handle it on the front side. Now, there is a caveat here. This application was chosen very specifically because if you actually read here inside of our authentication piece on our README, it says, currently every request is assumed. Anytime you see that word, that is a very big red flag. Is assumed to have come from an admin user. There's our problem. This allows access to the backend without the need to log in, allowing potential adopters to get a better look at what we'll be working with. Now, this is actually a common pattern and a common practice in dev environments, whether it's authenticating blanket a IP address or a user, or having a master user that QA could use so that they can do QA testing, or as our developers build endpoints, usually we build endpoints first, and we think about authenticating and authorizing those endpoints second, right? So let's talk about some of the ways that we can mitigate this. Unfortunately, today we're not going to go through and we're not going to mitigate this in code. We're not going to fix this in code because I don't have access to this right now, but we can talk about some strategies that we could use. The first strategy we could use is just flip the two. Authenticate before we authorize, and always, always, always authenticate, right? That's the first strategy we can take. The second strategy we can take is to make sure that even in a development environment or a QA environment, we are validating our credentials or authenticating everything every single time. So the second one is even in our dev environment, we want to be authenticating. A lot of people will cause fits about that. A lot of people will push back on that because it does make QA harder. It does make testing harder. However, if you were to forget that this existed and you did not go turn on your authentication and push to a production environment, you could potentially expose all sorts of compromising or all sorts of data about your users that you don't want to, that may be compromising. The third option, and to hop on the bandwagon, is to use things like artificial intelligence or machine learning to create anomaly detection, threat protection, and adaptive access control. That's a hybrid approach, which would allow you to essentially, inside of a development environment, keep things the way you have them and make sure that when you went to a production environment that you had the controls in place to be able to mitigate that concern. But the core purpose of what we did today is showing that not only can we catch this ahead of time before we push it to production, but that we can actually follow and see the reason behind why it's happening and where it's actually occurring. So by having AppMap as a tool that we use in our development environment, we could prevent this from happening as well. So that's the fourth option of mitigation, is making sure that we are double checking and testing and finding these things inside of a development environment so that they never go to production. Thanks everybody for joining me today, and we'll see you next time.